Okay, well, our general solution is just a linear combination of these two solutions. And again, commenting that this is supposed to work out. And I'm very sure these are linearly independent. I'm very sure it should and that it does if it's done right. And I've done something, just complete bonehead algebra, and something just isn't working out. These things can't all cancel, but it looks like they will. So we'll put that aside for a moment, and I'm going to ask you guys to work it out because you need to practice with the algebra. It's not that bad. Just do it right like I did. Okay, general solution then will be a linear combination, arbitrary linear combination of these two solutions. Okay, I'm using this form. Okay? So if we simplify that, we get this. Okay, very straightforward. You get a C1 plus C2 on the cosine term, a C1 minus C2I on the sine term. So here's a solution, here's a solution. Okay? Now, it looks like this solution's imaginary and this solution's real, right? But one thing we've got to realize is that C1 and C2 are complex numbers. We're dealing with complex valued solutions, so our scalars are over the field of complex numbers. Okay? C1 and C2 are complex numbers. So C1 plus C2 can be any real or complex number, right? So at the same time, C1 minus C2 can be any real or complex number. That's a big deal because it tells you, okay, from this and this, you can have two real solutions. Okay? Now I'm going to say that this solution set, okay, spans the solution space. Okay? And now we can make things much easier. Again, I probably didn't leave myself room.
So should there be an I in there, Mr. Smith, with the sign? Or
What?
not? Should there be an I in there or not?
No, because I
No.
just said that these,
But
oh, okay,
but with the sign, I mean, because. Oh, okay.
okay, well, since C1 plus C2 can be any real or complex number,
Yeah, it doesn't.
if you let C1 plus C2, or sorry, I've got that in the wrong place now. Okay, well, I'm just gonna say, since this can be any real or complex number,
Yeah.
then I times this can be any real or complex number. Just let C1 minus C2 be a complex number,
Right.
then I times that is gonna be a real number, right? But I'll say it. Okay? So this is the coefficient here, and this is the coefficient here. So what I'm saying then is that these can both be real,
Right.
even though you see that I there.
Without the I.
C1 minus C2 can be complex, any complex number, so that C1 minus C2I can be any real number.
Okay.
Okay? Okay, so, and again, I wrote something down prematurely. I could leave it there, it'd be correct, but let's do it in the order we're used to doing it in. Okay, so the derivative, of course, is going to be negative 5 halves e to the negative 5 halves t. Yeah, I don't know why I put a t there. Okay. Times the sine of the square root of 3 over 2t. And then it'll be minus square root of 3 over 2 e to the negative 5 halves t cosine. Sine. You know, that might have been what I did before. This would be a cosine, because I'm taking the derivative of this one, and this would be a sine. I'm pretty sure I did that right before, but it's one thing to look out for. Okay? So I think I've finally written these down correctly. But let me independently write down what I think I get over here. We get negative 5 halves t e to the negative 5 halves t sine square root of 3 over 2t. And then it's going to be minus square root of 3 over 2e to the negative 5 halves t cosine square root of 3 over 2 times t. Okay? Now, as before, this times this is equal to this times this. So I'm pretty sure that's 0. Okay? But write it out carefully just in case things go downhill from here. Because now this times this would give us negative square root of 3 over 2 times e to the negative 5t, right? And that's going to be cosine squared, and this is going to be sine squared. Okay? And hopefully, well, it doesn't matter. They'll probably come out with the same positive or negative sign, but no, that one would be negative cosine squared, this would be plus sine squared, right? Okay? So that's going to be times negative cosine squared, square root of 3 over 2t, and over here it's plus sine squared of the square root of 3 over 2t. Okay? And this can't be 0. Okay? Except if this is 0. Okay? Which it is when the cosine equals the sine. In other words, when cosine squared equals sine squared, which occurs 4 times around the unit circle. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Which makes me really, really not like that. And I really don't like it because we should get a solution for all values. Okay? There's no reason that equation should be discontinuous along those lines. So again, I suspect that should be cosine squared plus sine squared, so that you just get an e to the negative 5t, multiple of e to the negative 5t, which can't be 0. Okay? Okay, anyhow. So, main thing you need to see is that if we use this method with the Euler identity, we get down to something like this that gives you arbitrary constants, real or complex, in front of this term and in front of this term. And these are linearly independent solutions. Okay?